Okay, so I'm Amber. I work at Detroit Labs in Detroit, which is where Chelsea was an intern over the summer, so that's how I know her. I'm a developer, obviously. I do primarily iOS, Android sometimes, but I always test, no matter what I'm doing. Unit tests are very important. So, who here does mobile testing? Or, I'm sorry, mobile development? Okay, is that what you, okay. Who has never looked at any mobile code ever? Oh, okay, cool. I'll spend a little more time on that. What about just unit testing in general? Who's done any kind of unit testing? Cool. What about like Java unit testing? That's basically Android anyways. It's just like you have to put robo logic in the way and that's it. What about Objective-C? Okay. All right. Well, then let's get into that. So why are tests important? I think this is the best quote. If you haven't heard of Michael Feathers, which I'm sure you have, but he literally wrote a book about working with legacy code. Legacy code is being defined as anything that's hard to work with because it doesn't have any tests and you're, like any change you have to make to it, you're terrified that you're about to make 7 more bugs because it's horrible because there's no tests. That's legacy code. So he literally wrote the book about how to work effectively with it, and this quote is from him. Code without tests is bad code, like I said. It doesn't matter how well written it is, it doesn't matter how pretty or object-oriented or functional. If it was noun, he would put that in there. Or well encapsulated it is. With tests, we can change the behavior of our code quickly and verifiably, and without them, we really don't know if our code is getting better or worse. I love them. Okay, so has anybody done other kinds of tests, like acceptance tests or integration tests, or do you know the difference between those kinds of things? I don't know how much testing you guys get into here at MPAX. Blank looks, okay. All right, so unit tests are also commonly known as isolation tests. So basically what that means is you say we're talking about Java again, you're looking at one class and its public methods. You're gonna write a test that interacts specifically with those public methods. You have to do tricky things in the mobile world, which is very sad, like sneaking in and pretending to be Android or something, which isn't quite testing the public API, but it's close enough. So what that means is that you isolate everything that that object or function or that piece of logic is going to interact with. So instead of testing your whole system from, say, the UI all the way down to the database or the REST service or whatever it is, you're going to take this little chunk here that maybe goes off and gets something from the REST service. You're going to stub out the REST service, you're going to stub out anything above it, and you're going to test through the public methods what every piece of logic in that object would do given X scenario, and you have complete control over that. So that's unit testing for all intents and purposes. So iOS. Are you guys here more for iOS or Android?
Both.
Both? iOS? I was hoping everybody said iOS because I totally looked at my environment like an hour ago, and I can't show you very much Android stuff, but I can tell you about it. And I'll stick around after and I can show you stuff or answer questions. And that's the other thing too, I'm sure I glazed over some important stuff that I shouldn't have, so like if something doesn't make sense, just stop me and ask me to elaborate, or stop mumbling, either way. So iOS, what you need, if you didn't see the Facebook post I made earlier today, is CocoaPods. Do we have that stuff? Okay. So what CocoaPods is a dependency manager. Basically, you already know this if you work in Objective-C, but the only other way to have dependencies is to like download them and import them as libraries and literally store them in your repository and stuff. So what CocoaPods does, and it's a Ruby gem, is it will act like, well, basically like Ruby gems. It'll go out and find, given whatever the version string is that you give it, it'll go find that version of that library and install it locally. So you don't have to have that as part of your repository anymore. Kiwi, which is the next thing, is a CocoaPod. And you can have it for Xcode 4 or 5. Is there like a preference here, or 5? Okay. I actually use AppCode, but I have it set up to use the Xcode 5 stuff, so it'll be okay. And that's about it. That's basically all you need for iOS. What Kiwi is different than OC unit or XC unit. And I've only used those a little bit, but those are unit, X unit style tests, and we'll get into that in a minute when I talk about Java. But Kiwi is spec style testing. So what that looks like is this. you have your main describe, which is your system under test, your class in this case. You can use its as your test cases and assertions. You can group chunks of its that are related in context, which I think is cool. The other thing I don't have here is you can use something called a before each that would like run the same setup code before each it. But you can nest those down as many contexts deep as you want, and they won't leak out to the outer scope, which I love that, because X unit style is all like, it's a flat, you have that, and that's it, there's no layers. Yeah, so that's what Kiwi looks like. So for Android, you need Maven or Gradle, which would be your dependency management, but also your build tool. There's actually, I haven't worked with Gradle that much. I think it's just like a wrapper around, a groovy wrapper around Maven, but it actually makes the Android world a lot better. So there's a plugin for both Maven and Gradle that will wrap a lot of the ways that you can interact with stuff. So you just say build and then deploy to my phone, which is nice. JUnit, which is the testing library. Handcrest is a set of matchers that makes your unit tests a little more expressive. So instead of saying assert true, this equals this, or whatever, which sounds very programmery, you can use a language that's more like assert that, what was the last thing, your face? Assert that your face, and then you have a matcher that's is, and then you can use whatever that you know. Amazing. So it reads more like a regular English sentence. It's semantically, it makes more sense. It doesn't take that extra little bit of processing to be like, okay, what does this mean in English again? Makito is a super powerful stubbing and mocking library. And I meant to say that about Kiwi also. Kiwi has that in it, unlike JUnit, but Makito is like, I don't know, I can't live without Makito in the Java world. It's amazing. You'll see in a minute. Or no, you won't because it doesn't work. All right, you'll see when I upload it to the code base later. And then Roboelectric, which I don't remember if I was telling you guys or Chelsea now, but I'll say it again. The Android library, if you try to use it outside of an emulator or a device, it throws an exception that says stub, which is not useful at all when you're trying to unit test it. So Jake Wharton from Square made the Roboelectric library, which basically wraps all of that Android stuff, and then instead of throwing like some useless exception that makes your life hard, it kind of like pretends to be a fake version of Android, which is nice of it. It's a little bit tricky to get set up, which is what happened to me. You have to like use this other thing that takes all your Android SDKs and then puts them in like a local Maven repository. It's all crazy. So again, with Android, you're going to use XUnit style testing, and you can use spec style testing if you want to use a Scala library, but that's another talk for another time. So this is what XUnit style testing looks like. It doesn't look that different from our previous example, but you can kind of see in that second test where we would have been able to have a context and then put the it into it so that it's a little easier to parse. We just have a really long test name now. And it might seem silly in this contrived example, but if you think about it in a big complex application where you're going to have lots of different contexts and lots of different things to assert for each context, it gets a lot nicer. Okay, so let's look at the code. Who has the code? Are you going to follow along, or do you just want me to point at stuff?
Pointing would be good.
Pointing? Okay. Is there a pointer? Okay. Happy smells. Actually, for this, I'm going to mirror. Sorry, hold on 1 second. The only sad thing about mirroring is that everything becomes very hard to read. So this is app code, if you've never seen it before. It's the JetBrains version of Xcode. Well, it's a JetBrains Objective-C editor. It doesn't have the interface builder, and you can't get to like the build property stuff without looking at and parsing and changing XML directly. You can't release to the App Store with that, but I usually have them running side by side because what AppCode does give you is the ability to run a single test case, which I guess now you have in Xcode 5, but you didn't before. But case, not just class. I'm not sure if Xcode 5 does that. Yeah?
the tools that you talked about for Android, can you import that all into Android Studio? 'Cause that's
Yes.
typically what I use, or do you have to like run that all separately, like from the command line?
You can do it all through Android Studio, which is oh yeah, that's the JetBrains Android thing. So this is the JetBrains iOS thing. But anyways, yeah, you can put that in there. You can set up goals specifically for using anything that isn't already built in. But I think Android Studio takes care of all of that for you. Android Studio actually also, I think, will build you a template that uses Gradle, which is the build system I talked about. So that's cool. But you don't have to use Android Studio. I use IDEA and Eclipse. I don't know why I have to use like 3 editors for everything I do. So AppCode, what else AppCode gives you is really strong refactoring tools and code navigation tools, whereas like with Xcode, basically you're doing like a search all for globally throughout your project, which is not very fun. But with AppCode, I can say like, who uses this? Well, that's dumb. Yeah, here, who uses this dinosaurs variable? And then it will just tell me specifically that, and I don't have to worry about like if it's a string or something like that. Or if I wanted to change the name of this, oh, I won't put down. I can just change it, and it'll change it anywhere in the code that's using that, instead of having to do a global find place, which is super great. Okay, so this is the example code base that I put up on GitHub. There's a link on the Facebook event. Later there will be the Android example in there. I just have to figure out what I did wrong and push it. So what we have is just a basic list controller. You have your list of dinosaurs that you need to keep track of for one reason or another. And I actually made this as like a legacy rescue thing, so it's not the best code. It's supposed to be legacy code, but it gets the job done. So we have a way to go off to the service and get our dinosaurs, interact with our table view, and then we also have our table view delegate. Oh yeah. So how many people have used table view delegates and data sources and stuff in iOS? Okay, so that's basically the iOS way to say, given this list of stuff. So given this list, or I want to put a list of stuff here, just strings. That's how you do it. You have to use a UI table, data source, and delegate. So that's all this is. Just a really basic thing. Just shows you this list of stuff. You can click on them. You can see about all these dinosaurs. They're super cool and awesome. All right. So what do the tests look like for something like this? Look like this. So first things first, how to assert in Kiwi. So this should look familiar because it looks a lot like the example I showed earlier. But basically it just adds message selectors on anything that you want to test. So for example, I want to ask my controller specifically, given this set of dinosaurs, and again this is the isolation thing where you have to kind of be tricky and pretend that it already knew. But if it has this as its list of dinosaurs, it should know that it only has one row in it. So I execute my system under test here, that's my call to action, and then I assert that there's only one thing in there. This thing is a global macro that will take primitive types in Objective-C and make them, cast them to IDs basically, because Kiwi doesn't know how to work with primitive types. Seems like they could have just done that for me, but whatever. So you have the should that's attached onto, I think basically just the ID. And then you can use matchers from there. So equal is the most common one. So I'm saying this number should equal 1. You can do stuff like this. I have a fake label here. I've mocked it with Kiwi because I don't want to actually instantiate any view stuff in my unit test. Remember, it's all super isolation, and I only want to deal with specifically this code in this view controller. So I have a mock label, and I set that on my mock cell. That's going to come back when I try to make a cell for whatever, a given dinosaur. And I'm going to say that it should receive the set text selector with the dinosaur's name, because that's what I want the code to do. And then I do my call to action. So if we go look at our set text for cell thing, that's exactly what it does. So it finds the name for that dinosaur that you're trying to get at and sets the text on it. Super simple, super contrived, but this is what you would do in more complex situations as well. This actually is another example of a way to get at things that maybe are hard to test in Objective-C. So a lot of the view controller stuff, it's like this. You're going to be inheriting from a parent controller. Basically, you're putting a patch on a framework that exists, right? And you don't want to have to deal with the rest of the stuff around that. So if I want to be able to make a cell for a row and just test what happens with that cell, I don't need to test how to make a cell because that's already a thing in Objective-C. It's in every single app that exists. It's already, like, it doesn't need me to test it, right? So I can just extract the logic that I actually do want to test into another method and then test that. So I don't have to put that on my header. I can just, I'm in the wrong file. I can just make a private category for my spec specifically. So now that's not exposed for the rest of the production code. It's only exposed specifically for my spec file. It's another one of those tricky things that makes me a little bit uncomfortable in unit testing, but you gotta do what you gotta do. Oh yeah, stuffing. So this is just a library that helps make JSON requests to services. It's not really important what it does. What is important is that it's from somewhere else in the world, and I'm actually using like a class method to instantiate it. But the cool thing about, that's here. So there's no dependency injection here. It seems like it would be impossible for me to like put a factory there or something like that that would allow me to stick a mock there. But in Objective-C, I can stub whatever the hell I want, just because that's how the language works. So I say anytime this class from anywhere in the world gets this JSON request operation selector, then return my fake one, which is awesome because in Java you have to do a lot of, you basically have to make a factory and inject it and then mock that. So if we haven't done a lot of Objective-C, do we even want to talk about blocks? Yes, okay, because they're very tricky. So in this example, what we're looking at is the same kind of thing we did before, stubbing something that's global or something that exists out in the world. What I basically want this to do is to queue up this operation. So as soon as there's a spot available in the main queue, I wanted to show this alert view for whatever reason. And I don't remember which of these I'm testing, but one of them. So in here, instead of stubbing it and returning a fake queue, because that adds an extra layer where I'm trying to, I'm going to have to make a fake one, then I'm going to have to stub what it does, and I'm going to have to inject that somewhere. Instead, I'm just going to say, hey, if you ever get called this thing, oh, that is this. That's okay. So anyways, I can say if you ever get called with this add operation with block, just automatically execute the block that you're given, because I don't care about having control over that. I don't want to have to put some kind of asynchronous wait in there. I want to be able to just say, the minute you get this block in the context of this unit test, execute it. And then again, this is where the block stuff gets weird. So instead of matching the message selector pattern that you would have normally, stub with block will just give you an array of the parameters, and that's what trips most people up when they try to use this. But you just have to think of it as, instead of being laid out like arguments, like you would assume they are, just like turn them on their side and then pick the right index of them, if that makes sense. Anyways, yeah, and then you can just execute it. Yeah.
What's the purpose of stubbing something and returning a null queue instead? I'm not sure I understand.
So this is kind of a misnomer because it looks like I'm returning a null one, but I'm just injecting a mock version of it right now so that I can stub things on it. So because this has to return something that I have control over, I want to stub it and return the mock version so that I can then later say anytime you call at whatever it is, add operation with block, do this specific thing. Otherwise, they don't have a handle of it.
To do that instead of what it already does?
Yes, yeah. So what it would do is this block here would replace the functionality of whatever it normally would do. And that's the same thing stub does in general as well. I think I had a stub and return up here. So where calling text label on my cell would normally return the regular text label, this time it's going to return my fake label. And that's a little more obvious in places where you're not stubbing a property, but they're basically the same for all intents and purposes. Does that make sense? So it's like I was talking about having to use dependency injection in order to like kind of stop a real thing in its tracks and put your fake one in its way so that you can isolate and the scenario around that chunk of logic and test it. Instead of doing that, we can just like basically hack off the part we don't want to actually run, like add operation with block, and just do whatever we want. Does that make sense?
Yeah.
Okay.
So like, in that example, like, what's the reason that you're using stuff?
For this one?
Yeah.
Because normally this cell would get a UI label by making a real one, and I don't want it to have a real one.
So what do you do with the pop thing?
What I'm going to do is assert here that it received some selector. So I'm saying when I tell it to set the text on the cell, it's going to go to that cell, it's going to get the label, and then it's going to set the text on the label to be what I want it, what I expect it to be. I don't remember. I think I was at argument captures. I wish there was more real estate here, but this very long line is an argument capture line, and that's something that's very similar to stuff with block, but it gives you a little bit more control over how you handle the argument that you capture. So stuff with block, basically you're going to completely replace what it would normally do and then immediately execute something there when it's called. Argument capture, you can kind of grab whatever your method's getting called with and then use them later. You don't have to do it immediately. Or for example, this thing, I'm trying to capture the success argument to specifically test what happens on the success of this JSON operation as opposed to the failure. So I want to be a little more explicit about which argument I'm capturing instead of just executing all the things all the time. Does that make sense? Okay. Now, this is that thing I was talking about earlier, the asynchronous testing. I'm not a fan of that because that means you're not isolating all of your collaborators. You're leaving something open to possibly doing its own thing because it takes some amount of time because you're not stubbing it out, if that makes any sense. But if that's what you really want to do, then you can use should eventually. And basically it'll just pull until it happens or until it times out. And if it times out, then you lose instead of asserting immediately. I think this is more of the same. Yeah, this is the same kind of test we were just looking at before. So that's kind of like a whirlwind overview of how to do isolation testing in like a real iOS kind of project. The Android stuff that doesn't work right now is basically the same. The only difference is, like I was saying, you would have to use real dependency injection instead of just like stubbing a selector out because Java is a lot more picky about that stuff than Objective-C. But these kinds of like tricks and ways that you would work with something, they're basically the same idea in every language, if that makes sense. So, do you want to try something for real or not really? Yeah.
What's the best way to unit test when you have to query a lot of data from like a database and you don't necessarily have that data? It's like generated as more users use it. What's the best way to?
So what are you trying to test specifically? What is the thing that you're trying to do?
So let's say I want to make sure that, for example, you query a certain attribute from a table.
So you want to make sure you're building the right query to execute.
Exactly.
Personally, I would put a mock object over the database layer, whatever that library or driver is, or whatever that you would normally communicate with. Make sure that's abstracted away, and then inject a mock one and verify your interactions with that mock. So you're going to verify. So you could say, like we did here, you would say this database mock should receive, execute the query, and then your expected query. Do you have any other questions? Okay, I was gonna see if you guys wanted to try some exercises. We could do like an Objective-C one and an Android one, just kind of basic like kata pairing kind of stuff. Are you guys interested in that? Yeah? Okay. All right, so get out your Xcode or Objective-C or app code or whatever it is that you want to use. And find somebody to sit next to and pair with. So if you're not sitting next to anybody, you have to pair with somebody. You guys can come hang out down here if you want to too. It's kind of weird to pair. Let's up into the church. So this is an exercise we actually do at Detroit Labs on a weekly basis. We do a different language every week. And while it's not necessarily specific to Android or iOS frameworks, it gives you a good feel for how to work with any particular language and how to kind of unit test with it. So here are the rules. Once you found somebody that you're going to pair with, you're going to TDD, so you're going to write the simplest test that you can to make progress, even if it's like, this thing exists, then that's your first test. If it seems like what you're doing is kind of a stupid small step, then you're doing it right. You write only enough code to make that test pass, so if you write a test that says, your first test says this thing should give me a 2, and then you go to your production code, your system under test, and you just make it return 2, that's perfect. And then you only refactor on green, so if you want to change names of things or extract methods or extract local variables or whatever, change basically the way your code works, you can't do that unless all your tests are green, because that's your safety net. You're going to pair, ping pong style, which means you're going to write that very simple failing test, and not compiling counts as a failure. You're going to pass your keyboard or laptop in this case to your pair. Your pair is going to write that only enough code to make it pass, and then they're going to write you a failing test and pass it back. You're not supposed to finish the exercise, so don't freak out. If it's like the timer goes off and you've only gotten through like 3 tests, it's okay because you just learned how to write those 3 tests. And don't be a jerk to each other. So don't be negative. Don't be all like, oh, I wouldn't do it like that. Don't do any of that kind of stuff. This is like a safe place where you can learn how to write unit tests, and this is a new exercise that theoretically none of us have done. So do it. The exercise is the prime factors kata. And you can do, if you want to do Java instead of Objective-C, that's okay. I don't know what kind of environments you guys have set up, but I don't know how I'm going to walk around and help you like I normally would, but you can just raise your hand and I'll come help you. So given an integer, your code will return a list of prime factors for that integer. For example, if you give your method 2, then it's going to expect back a list of 2. That would be the right answer. 3 would be 3, 4 would be a 2 and a 2, and so on, forever and ever and ever. We got it? Yeah.
So to get started, should we start a project and then install Key with CocoaPods?
Yeah.
Okay.
Yeah, so if you guys installed CocoaPods already, and we can go through that if you want to. So we actually did this exercise today in C++, that's what that was. God, I have a lot of stuff. And that's from last week when we did go. So, do you have, Do you have CocoaPods already? Or are you gonna do Java? Do you have Java, do you have Maven already? Okay, so you're gonna make a new Xcode project. You can do it however you want, doesn't matter. And there'll be a checkbox around here somewhere that says, make a test target. You do want to do that. Okay, so if you did it right, then you should have a test target and a regular target. Are we all there? Got it? Does anybody need help? So silent here, what's happening? Okay, and I usually cheat and like copy my pod file from somewhere else, so. You basically want to make a pod file that looks like this. It's just called pod file with no extension, it looks like that.
And you don't need like platform or if networking, right?
You don't need AF networking, you do need platform. And you might need XC test on QB. Find out the hard way. You can make this 7 too if you're just using Xcode 5 and you don't want to deal with it. It doesn't matter. I've actually never done the XC test version, so this will be good. Oh, this will obviously be the name of your test target, not this. So mine is prime factors and, hey, out there. Really? What is this? Prime factors MX test.
What do we need the /XC test?
So that is because that's the unit testing harness that's in Xcode 5. Kiwi was built for OC test. They might have updated it so you don't need that, but I think you do.
Okay, I've used it before without having it, but
In Xcode 4 or Xcode 5?
Xcode 5.
And you didn't have to change any build settings?
Let me check my console. Yeah, I just need it.
Okay, let's try it out. Okay, so if you have your pod file ready to go, then do pod install. Your pod file must be next to your Xcode proj file. And once you do that, close your project. And then open the workspace that it just made. And it should look like this. Are we good? Okay, is anybody doing Java? Okay, so it doesn't matter, I won't do it. So basically, you can delete all the stuff that's in here. You can delete this file if you want it to be different, it doesn't matter to me. You're going to import kiwi.h.
I just missed, what did you delete there? Was it just standard boilerplate or?
Yeah, it was everything that Xcode automatically put into the project. We don't need it. Kiwi uses these macros. Spec begin. Give it the name of your spec. So what is this? Prime factors, max, s, whatever. And it doesn't have to match. It could just be prime factors. It's fine. You always have to end with spec end. And everything has to go inside of a describe. So for example, we had said to results in a list containing 2. Go. That's not it. Let's describe prime factors. I'm going to say it results in a list containing 2 when given 2, or I can get all crazy about it. We'll go from there. So I'm going to set a timer. Does anyone not have a pair that wants to do this? Okay, I'll stay for them. And I'm going to set a 20-minute timer and put the rules back up. Wherever the hell I put them. There we go. And go. I'll let you know when the timer goes off. We'll do a quick retrospective. Matt, how much longer do I actually have up here?
We can wrap up after we're done with this exercise.
It's up to you. It's just how many rounds we have time for and things like that.
Yeah, we'll try and finish up by 8.
Okay. Okay, cool. That's perfect. If you have a question, I will gladly come.
So what I have to do is I have to change the prime factor. Okay, and then I need to, so I have to write both the tests and change them. So is it a good idea to just put the actual prime factor thing, so I'm gonna do the test.
You can do that if you want to. You can make a new view controller. You can put it right in the spec if you want to. You can make it like a block. You can do it like a block.
So this should be a list.
Oh, yeah. I can't remember. Blocks and text on spot.
Go to fucking blocksandtext.com.
Is that what it is?
I think that's what it is. Yeah, fucking blocksandtext.
Amazing.
How do I write it?
Need this. Okay, so this would be like prime factors.
Hit Control V.
Thanks.
Control X.
Give me back whatever.
Nice. Control C. Control down. Hit enter. And I should.
Doing like JavaScript and Java all day. I
Press
can't remember how to do
Control
anything.
O,
Languages I need
Control
to
X,
do right now.
Now type fast all.
So anyways, you could just make it in line like that and then call
Oh, I should do that.
like that.
No.
What do we put in the line?
Oh. Right after that.
So how do I switch it?
Control X O.
Ah, yes, that's how you do it, right?
Has failed.
So right here in this format, and after last tilde A add tilde%.
Wonder why no one uses this. Is that like this?
Yes.
Alright.
So it's you're trying to install this.
No. Like control X, control O.
Control X O. No Control O.
Alright, and
You
then,
can just arrow up and hit test all at once.
so I have to load it again?
Really?
Sure, yeah.
It's smart.
No,
you do have to
you didn't load it. How do I load it?
Hit Control X, oh, you can do that,
Yeah, it's-
Control C,
yeah.
Control L. Okay. And I can make it so it'll just run the test on there.
Here we go. Alright, test 4 fails. Oh, is it Rebecca's turn?
I know, whoever wants to. Let me just add something.
What's CCC?
Do you want to do good copy?
Don't forget to take tiny, stupid steps towards the solution.
Oh wait, no, I was supposed to change the accusation motion. I didn't do that.
Yeah, I just add something.
Oh no, I was supposed to write, no, you were just supposed to write the 2 tests, then I was supposed to, okay, we're starting, so you need to write enough
Yeah.
code to make it work with 4. Then you pass it back to me, and then you write, you change the code to work with 4, then you write another test, and you.
Okay, so whose turn is it now?
Not me.
Okay. Okay, so you, wait, hold on, you made it past 4 and 2.
No, I didn't make it past.
So you need to make it past 4 and 2, and then you pass it back to me. Please don't enumerate.
I don't have to do this either.
You don't have contact with me?
Yeah.
So extremely quiet staring at me here. It's okay to talk to me guys while you're sharing.
Just write something that passes the test. We don't have to make it good right now. Just write something that passes 4 and 2, preferably without a numerator. You might have to enumerate. No. No, you are a person who does not be No, you want to.
That's why I'm writing. 281.
Okay. How do I make a function return something?
It's the last value performed.
So, oh, thanks. Hey, so,
That's not my.
you didn't add any new tests.
Oh, it's supposed to add a test?
Yeah, you're supposed to add a new test after you fix the code.
Fritz, how do I do protection for my header files?
You have to
the whole
define
word?
something.
Just look it up on your old 280 files. It's like an if and def, and then def, and then end if. I thought pragma once is what does it in C++ a lot of it.
Was it? I thought it was just like a Microsoft thing. Okay, we're failing 3.
Good. Right, so we're failing 3. Excellent. All right, I'm going to try to do away with not just enumerating it. But, I actually just want to write the algorithm now. We've done something. You've made it enumerated, and then we're just going to have a big chain of enumerating possibilities.
I could have. Okay, I'll make it past now. Def, enum, def, enum.
No, we don't want it to be an enum function though. We want it to be like a legitimate function.
Fine.
No, I'm gonna write a test which just doesn't work. parentheses do I need data?
You need
I want to add something up here.
Right, so you need to call a function. You need a space after the. This is gonna.
How do I return a list of numbers?
Just close parentheses.
I don't have to do nil.
Right, that is nil.
Am I missing a space? Did I do the wrong thing before?
It doesn't matter.
Like this?
That's fine. We need a space after the equal sign. So now you're just gonna try and call the function equals x. You need a parentheses at the end.
Yep.
Yep.
And how do I do else? I want to just like
Oh.
I want to add like an else after
Right.
1 but before 2.
What?
No, here. No, so where's the end of this statement?
It will tell you that here. Okay, you're in the rest clause, so if you enter,
This is the else. Right.
so you need to make open parentheses t.
Now I just do it.
Right. So if you call it as function, you had better put parentheses before it.
Oh, then it evaluates it first, right? Not sorry.
You need to put a
Stop snarking
No, this
and,
is not.
no, you need to put a space after the e, because now it's going to try and call the function prime factorized parentheses. Well, that might work.
What is that? Oh. like
Well,
this.
you don't need that parentheses.
Which parentheses? No, I'm passing an x over 3.
Okay.
That's how I need parentheses.
Okay.
So prime factorized x is x over 3. Then this is prime factorized. Then this is t. No, this is t. Then this is then this con. Then that's defined.
Right.
Okay.
Right.
So now I'm gonna make sure. Oh shoot! I didn't make that.
You're still failing 3.
No, I know. I didn't remember that. So I want to return the list containing so I want it to what? So okay, I wanted to make a list that says 3 and this thing. Is that
Okay, there's a
possible?
function called list.
Yeah.
And you call a function called list.
Okay, so T returns a list with input as 3 and this.
Right, okay.
Just forget
Yeah,
to
one more
take
time.
small
Yep.
symbols that.
Right, let me
Right.
check. Fun, okay. Oh wait, no. Did I just?
It runs automatically when you load it now.
3 still fails.
Look for the start.
3 still fails.
Everything below start.
Okay, what I want here is I want to make, it's making a list of 3 and the empty list. But I want this to be like nothing. Like I don't want to append it. Not, because at the moment it's 3 and then like a nested list. I just want it to be nothing.
Are you sure?
No, oh wait, I just do nil here. Up here, this needs to be nil. Right?
Yeah, I guess you need to change it.
That's what I want.
Yeah.
No, wait, there's just value. Okay.
Yeah, it should have.
That 3 still fails. What does it print out? I don't know what it prints out.
You can just type it right in the record.
I don't want it to be the word nil. I want it to actually just be nothing.
Wait, what? Let me see that.
You understand what I'm trying to do, right?
Yeah.
It just says 3 mil.
I got socks on my jacket. No. Pizza sauce on my jacket.
I want to return the nil.
Yeah, so you're both.
Yeah. Well, maybe it should be an empty list. I don't know. I don't like this.
Okay, I'm gonna call it done there so that we have a couple minutes to talk about it. Okay? All right, what'd you learn? What went well?
I got some test cases too.
Cool.
Yeah.
Cool. And like J in it? Or test MG?
Yeah.
Cool.
All the numbers have to be objects with a lot of bats.
Yeah, or you could use that, the value wrapper too, but yeah.
Well, we were trying to do the minimum amount of code, so we kept just writing functions that enumerated all of like the possibilities for the prime factoring, and so it was hard to like continue building off of the already poorly started function
Yeah.
without just like erasing it all.
Yeah, so that's an interesting thing to think about. At some point, the simplest thing to do becomes actually to refactor it and do something that makes sense instead of trying to keep going in the same direction. What did not go so well in the last, whatever, 15 minutes? Nothing, everything was perfect and awesome? First time ever. Okay. I'll leave you alone now. This is me and my stuff. I work at Detroit Labs. Chelsea said somebody might be looking for an internship or something. Let me know. I don't know what we're hiring for, but I'm sure something. And that's it. Thanks for listening to me ramble. And I'll try and get Android up by the end of the weekend, let's say that.